Hi guys, in the previous video we learned how PERT is useful to find the probability of meeting project target dates. So in this video we'll see practically using a problem how PERT is useful to find the probability of meeting target dates of a project or individual project events or tasks. So this is the previous video link. So go through this link there you can understand in a better way how PERT is useful theoretically. Now we'll see using a problem. Find the probability of finishing the project on or before 15 weeks for the following data. So what is the target date is given? The target date is given 15 weeks for the whole project, not for the individual activities. For the whole project, the target date is given. So we need to find the Z value for last event, the final event. Okay. So we'll see how it is possible. So these are the various activities are given from A to H and their precedence and their optimistic value or times, most likely times, pessimistic times. So using these information, we'll see how to find the probability of meeting target date of this project. That is whether it is finishing by 15 weeks or not. What are the chances to finish the project by 15 weeks? At the same time, the risk. So what is the first step in part computation of expected duration of all the activities? Expected duration. So how could you calculate the expected duration with the help of optimistic time, most likely time, and pessimistic time? So using these three parameters will form a mathematical expression, that is TE equal to expected duration time equal to A means optimistic time plus 4 multiplies most likely time plus B pessimistic time divided by 6. So using this mathematical expression, we have to calculate the expected duration time for all the activities from A to H. So for the first activity A, so what is the value of A? 5. 5 plus 4 multiplies 6 plus 8 divided by 6. So what is the obtained value? 6.17. The expected duration of activity A is 6.17. Similarly, we have to find for B. So 4. The expected duration of activity B is 4. So like this way, we have to calculate for the remaining activities up to H, the expected duration for all the activities using this mathematical expression. So for C it is 2.83, for D it is 4.08, for E it is 2.83, for F it is 10.50, for G it is 3, H it is 2.08. So now we calculated the expected duration of all the activities. Then we have to calculate the standard deviation of all the activities. So how could you calculate the standard deviation using the mathematical expression S equal to B minus A divided by 6. So what is B? The pessimistic time. And what is A? The optimistic time. B minus A divided by 6. So using this mathematical expression, we have to calculate the standard deviation value for all the project activities for A. So S equal to B minus A. What is B value? 8 minus 5 divided by 6. So what is the obtained value? 0.5. Similarly, we have to find for the remaining activities B 0.33. The standard deviation value for B is 0.33. For C is 0.17. For D is 0.25. Then for E 0.50. For F 1.17. For G 0.33. For H 0.08. So like this way, you have to calculate the standard deviation values for all the project activities. Now we have expected duration values, standard deviation value. First step and second step is completed. So what is the third step in part? Construction of a network. So how will you construct a network using activity on arrow approach? So that is explained in this video. Please go through this video how to construct a network for PERT. So construction of construction of network using activities and their expected duration values. Okay. So this is the link is used to know about how to construct a network. So for briefly I will tell you here also, while constructing a network, you need to check the various activities and their precedence. So so we have to start with the activity A. So this activity needs two events, the start event and the second event, that is the finish event. So it is not having any precedent, so we can represent directly. The same time we need to check whether it is a precedent for any other activity. Yes, it is a precedent for other activity, that is C. So we need to check again whether it is ending alone or ending with any other, that is it is ending along with any other activity, combinedly ending or alone it is ending. We need to ensure that. So it is ending alone, so we can represent directly, no issue. So the first activity A, it is a expected duration is 6.17. So its start event is 1 and its end event is 2. Then the second activity B. So B is not having any precedent, so we can represent directly. The same time you need to check whether B is the precedent for any other activity. Yes, it is a precedent for activity D and activity E. So we need to check whether B is ending alone or ending along with any other activity. So here it is ending alone. So no issues. Directly you can represent as a start activity because it is not having any precedent. So what is its start event? One itself, and its end event is the new event, that is 3. So start event is 1 and its end event is next C. So when C will start after A, because A is the precedent for C. At the same time, you need to check whether C is the precedent for any other activity in the remaining list. So C is the precedent activity for H. Now we need to check whether it is ending alone or ending along with any other activity. So it is ending along with D. So combinedly it is ending. It is not ending alone. So we need to ensure that while representing C, C should end with D. So now representing C, what is the start event of C after A? That is 2 is the start event of C and end event is new event, that is 4. Now D, while representing D, we need to check whether it is having any precedent. Yes, it is having precedent. What is the precedent? B. Now we need to check whether D is the precedent for any other activity. Yes, D is the precedent for H. So we need to check whether it is ending alone or ending along with any other. Yes, it is ending along with the C. So we need to represent D along with the C. So already C is represented. Now we need to represent D. So what is the start event of D after B? That is 3. And where it will end along with the C. So where C is ended at 4. So we need to represent D between 3 and 4. The start event of D is 3 and end event is 4. Then E. So when E will start after B, because B is the precedent. So at the same time we need to check whether E is the precedent for any other activity. Yes, E is the precedent activity for G. Now we need to check whether it is ending alone or ending along with any other activity. So it is ending along with F. So while representing E, we need to keep it in mind. It should end with along with F. So that we have to keep it in mind. Okay. E. So E, when E will start after B. So what is the start event of E? That is the end event of B. That is, this is the start event of E, and end event is new. Fine. Next F. So F is not having any precedent. So we can start from start event and where it will end. So F is the precedent for G and ends along with E. So we need to represent both should end at one event. So already E is represented. So F starts from first event and ends with along with E. So the start event of F is 1 and end event is 5. then G. So when G will start after E and F, so we have this combination. Which event is having this combination? We need to check that. That is the start event for G. So where these are meeting at 5. This is the start event of G, and end event is a new one, 6. Then H. So H, when H will start after CD. So this combination is required. So where C and D are ended at 4. So this is the start event of H, and end event is the 6. So like this way, we have to represent all the events for all the activities from left to right using forward pass. The steps are explained in detail in this link. Please go through this video. So we constructed a network using a expected duration of all the activities. Expected duration of all the activities. Now we have to represent standard deviation of all the activities. So we already represented expected duration. Now standard deviations. So I already calculated standard deviation that we will represent here. Standard deviation of A is zero point 0.5, B is 0.33, C is 0.17, D is 0.25, E is zero point 0.5, F is 1.17, G is 0.33, H is 0.08. So standard deviations are also represented. So 1, 2, 3 steps are completed. So we calculated expected duration, standard deviation, and constructed a network. Now what we have to do, the fourth step. So what fourth step says? Calculating the expected duration of every event. For every event, the expected duration. So how would we calculate the expected duration of every event? So for the initial event, what is the initial event? This is the initial event. For this event, it should be 0 because it is starting. You see, it is initiating the process. That's why its value, the expected duration of first event is 0. Then we have to calculate for the remaining events. So how will we calculate? The expected duration of previous plus the expected duration of activity. So what is the expected duration of previous? 0. 0 plus 6.17 for event 2. 0 plus 6.17. So the expected duration of event 2 is 6.17. Similarly, we have to calculate for the remaining. So for 3, what is the expected duration for 3? Expected duration of previous event plus expected duration of the activity, 0 plus 4. So like this way we have to calculate for all the remaining events. So for 4, how will you calculate? So if you see here for 4, it is having two previous events. What are the two previous events? One is 2 and the other one is 3. So what we have to do when we have more than one previous event? More than one previous event, take the maximum. Take the maximum. How will you take the maximum? 6.17 plus 2.83. This is one combination. The other combination is 4 plus 4.08. So what is the maximum value? 6.17 plus 2.83. This is a 9. So this is the maximum that we will take into account. Consider the maximum value. Same way, similarly for 5. So it is also having two previous events. What are the two previous events? One is 3, the other one is 1. So we have to calculate the expected duration for this 5 using these two paths. So this is directly 10.5. And what is this? 4 plus 2.83. How much? 6.83. This 10. So take the maximum. What is the maximum? 10.5. That we will take. Next for this. So how many previous events? Two previous events. What are the two previous events? 4 and 5. 9 plus 2.08. 10.5 plus 3. So which one is the maximum? This one is the maximum, 13.5. So this is 11.08. This is 13.5. What is the maximum value? 13.5. So that we will take. So like this way, we have to calculate expected duration of all the events in the project network. Then what we have to do, we need to calculate standard deviation of all the events in the project network. Computing standard deviation of events for the first event. For the first event, it is a 0. Why it is 0? It is initiating the process. That's why it is a 0. So how will you calculate for the remaining events for the current event? What is the current event? Second. Second is the current event. How will you calculate the standard deviation of previous plus standard deviation of the activity? 0 plus 0.50. So like this way, we have to calculate the standard deviation for all the events. So for 3. So what is the standard deviation for 3? What is its previous event? 1. Its standard deviation is 0. 0 plus 0.33. So how much? So like this way we have to calculate. Next. So if you see this, so 4 is having two previous events. What are the two previous events? 2 and 3. So we have two paths. So how could you calculate if more than two previous events for the current event? How will you calculate maximum of square root of sum of squares of standard deviation? That is, here it is having two paths, that is this path and this path. 1 to 2 to 4 is one path, 1 to 3 to 4 is another path. So we need to calculate maximum of square root of sum of squares of standard deviation. Square root of 0.5 plus 0.5 square plus 0.17 square, comma square root of 0.33 square plus 0.25 square. So maximum of this path and this path. So if more than one input activity, maximum of square of sum of standard deviation square for all existing paths. These are the two paths are existed. So 0.53. So like this way we have to calculate for the remaining nodes. So if you see 5, it is also having two possible paths. What are the two possible paths? 1 to 5 direct path, and the other one is 1 to 3 to 5. So here we have directly one value, that is 1.17. So maximum of square of 0.33 square plus 0.5 square, comma 1.17. So the maximum value will take. So maximum value is 1.17. Now in this case, so for this event, how many possible paths? Different possible paths. That is 1, 2, 2, 2, 4, 2, 6. 1, 2, 3, 4, 6. 1, 2, 3, 5, 6. 1, 5, 6. Max of path 1, path 2, path 3, path 4. Okay. One is the maximum value that we will take into account. Max of all these four paths. 1.28. So how will you calculate this? Max of square root of 0.5 square plus 0.17 square plus 0.08 square, comma square root of 0.33 square plus 0.25 square plus 0.08 square, comma 0.33 square root of 0.33 square plus 0.5 square plus 0.33 square, comma square root of 1.17 square plus 0.33 square. So maximum of all these parts, so that is 1.28. So like this way we need to calculate the standard deviation of all the events in the project network. So now it is ready. Now we have to calculate computing Z value. So here in the problem it is given 15 weeks. 15 weeks for which event? To find the probability of the project. So what do you mean project? For the last event. So 15 weeks are given for the last week. The target date is given for the last event. So we need to find the probability of finishing the project by 15 weeks. Suppose we want to finish the project within 15 weeks. So that is for the last event. So I will calculate a calculation of Z value for each event that has a target date. So which event is having target date? For that event only we have to calculate the Z value. Okay. So for the final event, the target value is given, that is 15. So for this event, we have to calculate the Z value. So we know how to calculate Z value, that is described in a previous video. So anyhow, calculating Z value. Z value is calculated for each node or event that has a target date. It is calculated using the following mathematical expression: Z equal to capital T minus TE divided by S. So here T is the target date that is given in the problem statement. TE is the expected duration of that particular event. S is the standard deviation of that particular event. So for which event we have to calculate? For the last event. Okay. So here what is target date? 15. Capital T is 15 minus expected duration of this event. What is that? 13.5 divided by S standard deviation 1.28. So capital T target date is 15 minus 13.5 divided by 1.28 equal to 1.17. The Z value is 1.17. So now we need to convert this value using standard normal distribution table. Z equal to 1.17 is converted into 1.1 plus. So now we need to calculate the Z value using standard normal distribution table. What is Z value? Z equal to 1.17. So converting into 1.1 plus 0.07. 1.1 on y-axis, 0.07 on x-axis. 1.1 0.07. So the corresponding value is 0.87900. So that is after converting Z value, equivalent Z value is 0.8790. So 0.8790 is equivalent to 88%. That is 88% of chance of completion of the project by the given target date by 15 weeks. So the probability of meeting target date is 88%. Similarly, the negative impact. So conversion of Z value in a negative way, that is Z equal to 1.17, that is 1 point converting into 1.1 plus 0.07, that is minus 1.1. Okay, and its corresponding not 7 value is 0.1210. So that is after converting, the equivalent Z value is 0.1210, that is 12%. 12% of chance of the risk occurrence in the project development. So like this way, we have to calculate the probability of meeting target dates of the whole project or individual project events if the event is having target date.